Good afternoon, everyone, and welcome to this week's Energy Futures Lab lunchtime webinar. My name is Conor McNally. I'm the Communications Manager at the Institute, and I'm very pleased to welcome you along to our webinar this week and to welcome our speaker from the Centre for Environmental Policy, Dr. Piera Patrizio. Piera has a PhD from the Energetic Engineering Department at the University of Udine in Italy. In 2016, she was appointed as a research scholar at the Ecosystem Services and Management Programme at the International Institute for Applied Systems Analysis, where she investigated alternative energy system decarbonisation strategies via CCS in various regional contexts. As I mentioned, Piera is currently based at the Centre for Environmental Policy at Imperial, where her work focuses on connecting insights from energy modelling with social science and climate policy, and includes the assessment of socio-economic benefits of energy system decarbonisation and the exploration of approaches that can foster the integration of knowledge across disciplines. So to tell you a little bit about how the webinar is going to work, Piera is going to speak for about 30 minutes or so, and then she will have time to take some of your questions. To submit a question, use the Q&A box on the right-hand side of the screen. And as always, if you could put your name and affiliation with the question, that would be very much appreciated. So with that, I will hand over now to Piera.
Okay, thank you very much. I'll just share my screen. Well, good afternoon, everybody. So today I'd like to discuss about my work, the work that I'm conducting at the Center for Environmental Policy, and that I've been conducting also at the International Institute for Applied System Analysis, where I was working as a postdoctoral scholar until December last year. And so the title of the presentation today is Socially Equitable Energy System Transition. And the starting point of the analysis is the fact that in any global challenge, also including energy transition challenge, we tend to adopt a silhouette approach, where generally we account for a specific aspect of a particular challenge, like for instance, the energy, the equity within the energy transition, or the techno-economic challenges related to a certain low carbon technology deployment. And this, of course, this type of silhouette approach can be seen in when tackling different global challenges, starting with energy poverty, climate change, water scarcity, and of course also the decarbonization of energy system. And so the risk of this type of approach is a risk of having a monocular view, and therefore addressing only one particular aspect of this global challenge without considering the interlinkages between different disciplines and also different, for instance, region or spatial context. And this can be seen also when we talk about climate change and energy decarbonization in the scientific literature. We see that, of course, there is a lot that has been done in terms of modeling the low carbon technology deployments within different regions. But all of these high-level technical discussion, a lot of time miss the social dimension of the discussion. So, for instance, there has been a lot of discussion around the possibility for achieving, for instance, ambitious climate mitigation targets with a focus on the demand side of the problem. However, the feasibility of these pathways is really not exactly or not specifically addressed. At the same time, when we talk about the socio-economic dimension of low carbon energy transition, we see that we have, again, a high-level discussion around the trade-off between different SDG, for instance, so between water issues together with food security and so on. But all of this discussion is remain quite qualitative rather than quantitative. And so what is missing is actually an approach that can actually link together these different aspects and quantify the effects of, for instance, low carbon energy transition in different spheres and dimensions, not only the technical or the economic one, but also the socioeconomic and the equity one. And so why this is important? It's important because after the Paris Agreement, we all agree, and the different countries agree, that it's necessary to achieve net zero, actually by mid-century, and all the different economies have actually made efforts towards these goals. However, in the same, like after the Paris Agreement, only 3 years after, and in the same country, so in the same city, actually in Paris, we've seen the rise of the Gilets jaunes. And what this movement has taught us is that actually, if we decide to implement or suggest policy measures that try to tackle climate change without really accounting for the spatial dimension of this policy effect, and also of the socioeconomic condition of the different local communities that are going to be affected by the implementation of these taxes, then we might end up with a social conflict and massive protest. And why this is important? It's important not only because we want to try to make carbon taxes effective, because it is clear that in order to decarbonize, we would need a carbon tax. But it's also important to understand what are the effects of applying this carbon tax on the different layers of the society, in order to avoid, of course, social conflict and to make this policy measure actually effective. And so the idea of my presentation today would be to actually try to illustrate two different case studies in which I combine these techno-economic analysis of energy transition with a socio-economic tool that actually take into account the regional disparities, but also the regional strengths and weaknesses in order to achieve this low carbon transition. And this is done in two different case studies. One that actually looks into the potential for social value to shape low carbon energy transition towards net zero by 2050 in different economies. And another case study that actually take a deep dive within the UK and try to understand if actually it's possible to conduct the industrial decarbonization that's it's actually in the political agenda of the government, and at the same time try to level up the spatial and regional disparities that are deeply rooted within the UK. So with regard to the first case study, as I said, again, the idea is to see if it's what is the optimal way to conduct the energy transition in different regional contexts, and if it's possible to actually use the value, the social value, rather than the least cost, so the cost minimization, to conduct this transition. So just to give a little bit of background with regard to the decarbonization and the environmental protection efforts of the European Union, I just present this storyline that goes from 1992 with the Maastricht Treaty until the Green Deal in 2019. And so we see that within this time frame, we had the European Union had put in place different policy instruments and different directives that were actually aiming at developing, for instance, renewable energy further and try to put goals that could actually help the different countries to achieve the net zero target that had been put in place. At the same time, together with this narrative of environmental protection and, of course, sustainable development, we have another narrative, which is the just transition narrative. So the just transition is, of course, not a new concept. It dates back to the 70s. And the idea, the concept relates to the needs of accounting for the just transition of the local workforce when we actually want to achieve the decarbonization or the transition of a particular sector towards a low carbon economy. So within Europe, we have seen that this just transition concept has been emerging already starting from the COP21 in 2015 that actually recognized the needs of a just transition of the workforce. Again, as I said before, in 2019, we actually had the coming up of the Yellow Vest protest in France that actually were trying to claim the need for the carbon tax or for any policy measure to be spatial in the sense of accounting for the local, the need and the local strengths and weaknesses of the different region. This concept of the just transition has been already again brought back in 2018 with the COP24, when the different delegates actually signed a solidarity and just declaration, in which they were actually pointing out the fact that any low carbon mitigation, like any emission mitigation measure, would actually need to be underpinned by economic development. Following all of these arguments, in 2019, the European Union have put in place the Just Transition Funds together with the multi-financial framework. And then in 2020, we have seen that, of course, the emergence of COVID and also of other political discussion around these Just Transition Fund that actually are jeopardizing these efforts. And so the idea is actually trying to combine this very different narrative, the just transition one, together with the efforts of the European Union to achieve the net zero target by 2050. And so the way that this case study has been built upon is by creating this framework, which is called ISO and JEDI. This framework, it actually coupled together a energy system optimization model that has a detailed representation of different low carbon technologies and a socioeconomic tool that account for different socioeconomic indicators within the economy. So the idea is actually to try to investigate in the different layers in which the energy transition is happening. So not only the technological one or the economical one, which are the ones that generally are accounted for in energy system modeling, but also the societal one and the energy system one. So how this is work is that this ISO model not only has a objective function that minimizes the cost of a particular transition, so account for the different low carbon technology and try to identify the least cost optimization pathways that can actually help to achieve a certain target. But it also has another optimization objective function, which is the minimization, the maximization of the gross value added, which is a measure of the economic turnover of a certain investment. So instead of accounting for the GDP, we actually accounted for the gross value added. And this is embedded in the objective function. And therefore, what we wanted to do is to use this framework within different case study and within different countries that has completely different economic structure, mean to conduct this energy transition, and also resources available, and see what actually is the what are the difference in terms of low carbon technology deployment when we maximize the social value or when we actually follow a conventional least cost approach. So this framework has been applied to 3 countries, as I said, that have been picked mainly because of their economic differences and technological means. And these are the UK, Poland, and Spain within Europe. And this is the a detailed representation of the JEDI model, as I said. So how this model works, so this is the socioeconomic tool. And how this works is that the tool is disaggregated the investment that is required for installing and deploying a certain low carbon technology within the different sector of the economy. And then it contains indication of the main socioeconomic metrics within a certain economy, like for instance, the gross value added, the employment rates of that is associated with a certain technology, and so on. And by combining these 2 different metrics, we actually have a an indication of the impacts of investing in a certain technology in terms of value added and jobs, but also indirect impact. So the impacts within the different sector of the economy associated with the requirements for certain material or certain services associated with a certain investment. And so just to show the results of the application of this framework within these different countries, we can see the results that we obtain when we look at least cost approaches in terms of energy transition between these different countries. So here we have Poland, Spain, and the UK. And here we can see 3 different scenarios. A scenario in which we have a business as usual, so a scenario in which actually we are not following any low carbon mitigation, any low carbon targets. A scenario in which we are actually trying to reach net zero by 2050 by deploying all the different technologies. And then another scenario in we actually allow only renewable and storage to be deployed without the presence of low firm capacity associated with nuclear and, for instance, CCS. And the reason why we wanted to also show these different 2 scenarios is because there has been a lot of discussion around the possibility for renewable, 100% renewable scenario to actually create jobs and value for a certain economy. And especially from a technical economic point of view, this type of scenario are actually generally welcome, and they are also indicated as potentially feasible for the energy system. And so what we see in this 3 graph and in this comparison is actually that when within a business as usual scenario, all of these 3 countries start to rapidly implement renewable energy, even without the need for a carbon tax, followed by, of course, because of the rapid cost reduction of these technologies. a scenario in which we have all the technology available, including nuclear and CCS, so a introduction already by 2030 of CCS, either retrofitted or newly built, especially with gas. And then in the renewable and storage sector, we see a rapid deployment of renewable, especially of wind, and a increased installed capacity that it's almost 4 times a business as usual by 2050, especially in the UK. So these two lines represents the capacity that are installed in the old technology and the business as usual scenario respectively. And so we really see how this capacity explodes when we actually only consider the presence of renewable energy. And so what happened when we actually, instead of following a least cost optimization approach, we try to maximize the value. And so we try to actually look at the existing resources of the countries. We see that, first of all, the energy portfolio is extremely different and varies between the countries. In Poland, we have the use of coal, of course, associated with the CCS in order to reach the low carbon target. And we see that CCS is actually already peaking, start to ramp up in 2030. Spain has a very different scenario, and we see that wind is also quite present within the energy system, thanks to the presence in Spain of wind and solar industry that actually allow to create this technology and retain the growth, economic growth associated with building this technology within the country. And while for the UK, we actually notice how the following value maximization approach as compared to a least cost approach achieve quite of similar results in terms of energy technology mix. We have a bit of a reduction in wind technology. And this is especially because in this scenario, we made the assumption of CCS being deployed within the country without the need for importing any particular knowledge, given the past experience of UK with regard to CCS projects. And so when we look at actually the effects in terms of socioeconomic impact of this transition and of this different sector, we can notice how these three scenarios actually perform very differently within each country. So this is the case of Poland, and on the top of the slide, we can see the performance of each scenario with regard to different SDGs. So here we have the SDG 8, labor and economic growth. In the middle, we have the industrial innovation, and then we have the reduction of inequalities, which is associated with SDG 10. And so what we see is that these three scenarios, especially with regard to Poland, actually show a negative impact for Poland, meaning that any energy transition by 2050 would actually create socioeconomic damage. And this is mainly associated with the fact that Poland is highly reliant on coal, like 80% of the economy is actually relying on coal. And of course, even with the coupling of CCS, especially the mining sector, as we can see here on the low part of the figure, is the sector that is going to be affected the most by this transition. And so in a way, the claim of the Polish policymaker in the fact that the low carbon transition is actually going to be very impactful for the economy are actually true. When we look at Spain, we have a completely different picture, and this is especially given by the fact that Spain has within the economy a quite big solar and wind industries that can actually help supporting the transition to low carbon by 2050. And so what we see is that, again, for each scenario, we have a growth in employment in each scenario, which are actually pronounced in the equity scenario, so in a scenario in which we are maximizing the value. And this is because, of course, by maximizing the value, we are actually trying to create more energy and create more growth with the existing industries, and therefore especially the manufacturing sector is achieving the highest growth in terms of not only employment, but also in terms of value added. In the case of the UK, we have again a very different picture, and we see how these two scenarios, so the scenario in which we have CCS and in which we are maximizing the value, are the ones that actually help to obtain some economic gain with the transition, although these gains are quite little. And actually a 100% scenario, so a scenario in which we are actually trying to deploy only renewable, is the least beneficial for the UK. And this is because, of course, being UK a service-based economy, the need for firm capacity is quite important. And therefore, in order to achieve so, UK will need to deploy an overbuilt and an underutilized energy system to meet the demand, which would, of course, create extra costs that are not retained within the economy. And so this is the conclusion of this first case study. What we try to show is that actually, when we only look at cost, we might end up saying that climate change mitigation and energy transition is only going to create economic losses. But actually, there is a way in which we can create value with this transition. Another important piece is that copycat policies do not work, but we really need to account for the regional weaknesses and regional strengths of the different countries. And therefore, if we want to deliver technically feasible, financially viable, and socially equitable net zero transition, then we need to adopt technology agnostic transition that account for local conditions. And so this was the results of the first case study. I'd like to now present a second short case study that I'm just start to developing now, that look at the possibility of implementing this approach also at regional level, and especially with regard to the UK industrial decarbonization challenge. Why so? The reason is that regional inequalities and productivity issues are actually both related to the UK industrial decarbonization challenge. This is because there is a long history of productivity gaps between the different regions of the UK, and also because, unfortunately, the industrial cluster, which are the ones that most probably are going to suffer economically the most from the transition to a low carbon economy, are also the ones that lag behind in terms of productivity. So we have this outperformance of London and of the Southeast in terms of productivity and economic growth. And then we have the other industrial cluster that actually are seeing the productivity going down over the last 10 years. And so the problem is the way the industrial appraisal and investment appraisal are actually accounted for by policymaker and also in literature, is by looking simply at cost metrics, either by looking at a cost-benefit analysis in order to, in the sense that an investment is judged to be economic meaningful if there are actually value creation, economic return from these investments, or by cost metrics, in the sense that generally, as I said before, in energy system modeling, what we try to do is to minimize the cost of the transition rather than looking at the opportunity for value creation. And so the point here is that in order to address this challenge, it's important to adopt a disaggregate approach that recognize the strengths of each region. And so what I've been doing recently was actually trying to adopt the same approach, so combining a techno-economic analysis with JEDI, so with the socioeconomic tool, and dive into the regional characterization of each industrial cluster. And so the idea is that we need we adopt a modeling approach that takes the UK existing spatial economic layouts, not only in terms of sectoral disaggregation, but also by accounting for the turnover and the gross value added of each sector at regional level, and also the trade in goods and services between the different sectors and across the region. And this is in order to capture, of course, import and export interdependencies and also potential ripple effect across the economy. And so this framework, what I'm going to show here is an illustrative example in which we try to see what would happen if we would invest in, for instance, an hydrogen plant, as an example. And what we want to see is what sector within the UK economy are most likely going to be affected, considering their relative size within each region, but also whether these investments has the potential for leveling up the inequalities and the productivity issues among the different regions. And so just for an example, we take 3 different industrial clusters that are represented here. Here we have the Humberside, the Merseyside, and Southampton. And we try to see what are actually the socioeconomic impact of investing in an hydrogen plant within this cluster. So what we have here is the socioeconomic impact of investing in an hydrogen plant within these 3 industrial clusters aggregated together. So each sector here is ranked in relation to the change in the gross value added, and the dimension of the circle represents the standard deviation that indicates which sector changed ranking position with within these different industrial clusters. And so what you see is the mostly affected sector are mainly the manufacturing sector, so the chemical and the machinery sector, because these are the highest in ranking, but also have the small standard deviation. And at the other end of the spectrum, we have sectors such as the finance, the ICT, or the retail sector, which of course are least directly affected by an investment in an hydrogen plant. And also what is very interesting to notice is that the standard deviation of this sector changes, which means that the relative size of the sector within a particular region plays an important role in terms of socioeconomic impact. And in fact, when we look at the ripple effect of investing in an hydrogen in technology within this different sector, and how the different local economy are going to be affected, we notice very much of a difference between these three industrial sectors. So we see, for instance, that the Merseyside, because it's not really well connected and the trades with the other region are quite little, affects also relatively little compared to other cluster, and this effect can be seen mainly in the Yorkshire and in the Northwest region, especially with regard to the construction sector. What is also interesting to notice is that the other two clusters, so the Amberstead and the Southampton cluster, show a higher ripple effect that are also spread out in the different regions of the UK. And also the size and the magnitude of this effect is different. So for instance, if we take the Southampton cluster, of course, this region is the one that trade the most with the south region of, like, for instance, London and the Southwest. But if we look, for instance, to the ripple effect that this investment has in London in the research and development activities, we saw that this is quite little compared to, for instance, an investment in the Northeast or in the West Midlands. And this is because the research and development and the business sector in London is already quite developed, and therefore investing in this particular region would actually not have the effects that the multiplicate effect that would have in another region, for instance, in the Yorkshire. And so just to conclude this case study, what we wanted to show here is that actually the industrial decarbonization might represent an opportunity instead of simply a challenge to address regional inequalities and also to improve the productivity and close the gap, the productivity gap between the different regions. One important piece is that, of course, the regional strength, but also the connection between sector and places play an important role in actually creating value when we are thinking about low carbon investment. And that the key here is, again, to look at the regional demand and consumption patterns in order to see how actually these different regions are interrelated with each other, and how we can actually level up the different productivity and economic performance of the different regions. And so this is all from my side. I hope you enjoy the presentation, and I'm looking forward to your questions.
Thank you very much, Piera. And just to remind everybody who's watching that you can submit your questions through the Q&A box on the right-hand side of the screen. Perhaps while we're waiting, I'll take a moment just to tell you about next week's lunchtime webinar. So next week we'll be joined by Professor Ricardo Martinez-Botas, who is Professor of Turbo Machinery at the Department for Mechanical Engineering, and he'll be speaking a little bit about the focus will be on the drivers of CO2 emissions in transport vehicles, and he'll also speak a little bit about his experience of and some of the findings, the learnings of an investigation he oversaw for the Department of Transport into the Volkswagen emissions scandal in 2016. So you'll find all the details of that webinar on our website as usual, and sign up in the usual way. But for now, I'll hand back over to Piera and some of the questions that are coming in.
Well, so I got a question with regard to the possibility for applying this framework to the transport sector as well. So this is, of course, possible. What is needed is, of course, the representation of the investments that is required for the transport sector. For instance, if I take into account the electric vehicle, for instance, what is needed is to simply consider the capital and operational investment that is needed, and therefore by that we kind of like have the cascade effect in the different sector of the economy and the socioeconomic impact that are created. So this is one. Okay, so sorry, I think I'm gonna read it. So yeah, so this is it used. The question is if the model used input-output table, which is absolutely correct. And the question is if this leads to a bias toward existing industries in a region. For instance, at the moment, Poland might not have a thriving domestic renewable industry, but that doesn't mean that by 2050 it could have one. Can you account for these structural changes and the potential for building new industries in countries? Yeah, I mean, this is a very good question, and it's really true. So the model can account for these different changes within the time framework, but this is at the moment exogenous, meaning that the JEDI and this framework do not account for structural changes, for instance, for automation or for the advent of a disruptive technology within the optimization model. So what we are trying to do is actually trying to make different assumptions in terms of specific, the advent of specific technologies. For instance, what happened if Poland would actually start to build its own solar plants. And this is something that we can model, but at the moment not really take this as endogenously into account in the model itself. Do you think your model could answer question on how to avoid this negative impact in terms using general equilibrium for Brazil? And I had some reduction. Sorry, I'm reading it again. I have done some work similar to this using general equilibrium for Brazil, and I had some reduction in employment and GDP. Do you think your model could answer question on how to avoid these negative impacts? Well, so the model, of course, also sometimes get as a result that investing in a certain technology can actually create negative employment impact and GDP. And so at the moment, the suggestion that can be made are by comparing different scenarios within each other. So the model actually maximizes the value, but does not give suggestion, if this is the question, on how to actually avoid certain negative impact within a specific scenarios. So this is something that would need to be interpreted. So this is a question. Thank you. So the conclusion for the UK, not offshore wind, is quite contrary to current development. How robust is your conclusion? How sensitive is to different input assumptions? So yeah, this is really true, especially for the UK. So I think that the question here is with regard to the comparison between the wind offshore industry and the CCS industry in the UK. So the disclaimer here is, again, that the assumption that I've made is that the CCS industries would actually be created locally, meaning that the UK already has the resources and the knowledge for developing a CCS industry within the country. An important bit is also that when we consider wind or when we consider renewable energy technology, we really need to look into the trades of the material that are needed for building this technology. So for instance, 70 or 80% of the global solar industry is actually located in Asia, meaning that whenever we invest in solar panel, we are not really creating value for the local economy because we are purchasing this material outside the country. And the type of value that we are creating are value, especially in the maintenance sector, for instance. And we are actually disrupting potentially other important local sector of the economy. So, of course, there are a lot of assumptions that try to reflect as much as possible the current data and traits, but this assumption can also be challenged, and the sensitivity analysis can always be conducted. So here the question is if this type of study can be deployed also for the developing world, for instance, in Asia and in Africa. And yes, as long as the data can be provided, this is for sure the case. I think that actually conducting a case study, especially in Africa or in India, would be quite interesting also to look at the effect, I would say, more on the energy poverty and energy access issue rather than the employment impact. And this for sure would be kind of like meaning to extend the range of SDGs that we would like to look at, but would be for sure an interesting case study. So it's just a matter of taking out as much as possible data of the economic structure of the different countries. So, yeah, I hope I answered to these questions.
Super. Thank you very much, Pia, for your time today and for that really interesting webinar. And thank you to all of you who joined us today. We hope you will join us again for next week's webinar. As I mentioned already, all the details are available on the website. And if you missed any of our previous webinars, they're available on YouTube. So until the same time next week, have a great afternoon. Bye-bye.
Thank you.